So let's see the problem number 30th from test 2, specifically from maths, calculus. What is asked is the coordinates xy of the center of gravity. Maths as well as you can say engineering mechanics, it's a combined problem, multi-discipline. So coordinates xy of the center of gravity is asked in the region x square plus y square, and given that x is 0 and y is 0. So it's basically a quarter circle. So in this region the xy coordinate of CG is asked. So okay, so the center of gravity is given basically by this formula. And we know that mass is nothing but rho into the area. So this is the area density and the thickness. Center of mass of density is given in the region. So basically the area density is given. So rho into dA, and rho is 1. So it's basically dA. So I can write x bar as x dA by, the dm is equal to rho dA, which is rho is 1 given, so it's integral dA, or not to write dm is equal to dA. That is what we get from here because rho is 1. So integral h dA by dA, and y bar is also integral y dA by dA. So as you can see that if we find out x bar and y bar, y bar, because the figure is symmetric about x and y, so if we can find out either of these x or y, that would be, the answer will be same for both. So let's find out x bar. Okay, so what we do is we take a strip actually. Okay, well, let me find out y bar. That would be good because we take a horizontal strip. Okay, and which is this is y, and the strip width is dy. Okay, so we need to evaluate this integral. So y bar is integral y dA by integral dA. Okay, so the area of this will be, this is x, this distance, so it will be y, area is x into dy. Okay, and we know this integral dA is nothing but, this is a quarter circle, so I can write pi a square by 4, this integral dA, which I can directly write down, or you can evaluate also. Now x here in the top integral, x I can use the circle equation, which is this surface is x square plus y square is equal to a square. Okay, so x square will be a square minus y square into dy, and this varies from 0 to a. So I need to evaluate the top integral. For that I substitute y as a sin theta. So my dy will be a cos theta d theta, and the limits as y varies from 0 to a, theta varies from 0 to 1. Okay, so let's use this to evaluate this integral. 0 to a, y integral a square minus y square dy will become 0 to 1, y is a sin theta, and this term will become a cos theta, dy will be a sin theta. So it will be basically a square a cube sin square theta cos theta d theta. Okay, so this is nothing but this, it is like x square dx. So the integral will be x cube by 3, so sin theta whole cube by 3 with the limits 0 to 1. So this will be basically when you substitute the limits, it will be a cube by 3. So when you substitute back this in this, you will get y bar as a cube by 3 pi a square by 4, which is 4a by 3 pi. Now x bar is also same as y bar because already mentioned that it is symmetric. So the coordinates of CZ are 4a by 3 pi comma 4a by 3 pi. So the answer is A.